Okay, good morning, everyone. Welcome back to the, I think, fifth class, although class 2 is written on the slide. Just to recap very briefly, I think this one is third class, not fifth class. So just to recap very briefly, in previous class, we talked about different tools and techniques, and then we also talked about how important the remote sensing is as a tool or as a technique. By technique, I mean the techniques of remote sensing, the techniques of data collection. So from now on, we are going to focus on remote sensing. So my class will be divided into two parts. In the first part, we will be talking about remote sensing. We will be dealing with the practical aspects of remote sensing, applications of remote sensing, as well as the theory behind it. How do we collect data? What are the platforms, and so on? And what are the theories involved while exploring the remote sensing? Then we will do a brief practical of remote sensing, or there might be few practicals of remote sensing where we will learn how to access data, how to process data, how to prepare data for further analysis. After that, we will move on to the next part of this course. And in that part, we will be doing some other things. That means we will be exploring some other tools and techniques that might be handy in disaster management. So one of those tools and techniques could be Excel or SPSS for data analysis, because remote sensing, it will give you the idea of how to collect data, how to access data, how to process that or prepare the data for geographic analysis. I mean, that analysis can be done quantitatively, that is for sure, or that will be quantitative. However, if you have other sorts of data, for example, the data collected by questionnaire survey, and the question you might ask, or you might face some difficulties in processing those sort of data which are not remote sensing or remotely collected data or remotely sensed data. So how to do that? So to process those data, we can use multiple softwares or multiple platforms. So one of them, those software is SPSS and Excel. So you can easily convert one questionnaire into SPSS, and then you can do further statistical analysis. So I know that you do not have much background on statistics, but you might not have much background on statistics, since that subject is missing or that course is missing from your undergrad curriculum. Therefore, we will have brief discussion on statistical theories as well. And then we will move on to the practical part of the second part, that is how using the softwares. And if you like, I can also show you how to do the things in or by using programming. So just let me know, but let me know before midterm that you would like to explore the programming part of the data analysis, because you have already done Python, and Python is very, very popular for data analysis and data science. So we can easily adapt that programming language and then do further exploration in data manipulation and data analysis. So, but I have to prepare the slides. I do not have those slides prepared, or I do not have the lessons prepared. So please do let me know before midterm whether you are interested or not. Excuse me. So let's move on with today's lecture. So remote sensing. There are multiple definitions of remote sensing. And one of the definitions is from Natural Resource Canada. And it says remote sensing is the science and to some extent art. And because of this phrase and to some extent art, I like this definition. So let's read. Remote sensing is the science and to some extent art of acquiring information about Earth's surface without actually being in contact with it. So that means remote sensing is something, just like I said in my previous classes. Sometimes the definitions in English or the words in English are very intuitive. Okay, so you see the definition here is remote sensing. That means you are sensing something remotely or from remote. So remote is you are not being in touch with the object that you are going to sense or you are sensing. Remote means you have some distance, or sometimes you have even further distance between you and the object of interest. Okay, so that is what it's saying, that remote sensing is the science. So just like GIS, okay, this is science that we are talking about, not the system, not the tools. We are dealing with the science here. So remote sensing is the science of acquiring information about Earth's surface. So you are acquiring information of the Earth's surface, right, without being in actually touch with it. So, or contact with it. So that means you are farther away from the surface. You are farther up, maybe, or down. So most of the time it's up, and then you are taking some photos or taking some data, collecting some data without touching the surface. So that is remote sensing in a very simple term. And I said the remote sensing is the science. So you may ask, so when can it be tools? The answer is it can be tools when we are talking about only a single remote sensing satellite or device. For example, if you talk about Landsat, then that one is a tool. That one is a remote sensing tool. That is not science. Landsat satellite is a tool which is using remote sensing as a science. Okay, so we know the science, we get to know the science, and then we take the Landsat and we apply that science with Landsat. Okay, so from that perspective, Landsat is the tool, or any satellite or any plane or drone, anything that you use, they are tools. They are not science. Okay? They are the scientific tools. So the next phrase or next sentence is that this is done by sensing and recording reflected or emitted energy and processing, analyzing, and applying that information. So you see, from this definition, remote sensing has two parts. In the first part, it talks about that, okay, so this is the science by using which we gather data without physically being in touch with the object. And the second part of the definition is saying that we do that sensing, okay? We complete that sensing, and then what do we do is we also record that sensation. And what do we record? Well, whenever we're talking about sensation, so for example, you are sitting, it's a wintry morning, and then you are in the village, and then you lit up some fire, okay? In your in the yard of your village home, you lit up some fire to warm up yourself, or it could be evening as well. So when you are warming up yourself from the heat of that fire, what do you feel? You feel heat, right? You feel warm around you. The warmth is coming from that fire. That fire is releasing some energy, right? So that means it's emitting some energy. So in day-to-day English, we say releasing some energy, but when we come to physics, we say it's emitting the energy. Okay, so emitting and releasing, they're same. So it's emitting the energy, and then that energy is falling onto you, and you feel that energy now on your skin or on the surface of your body, and then thus you feel that it's warm. Okay, because energy gives away the heat. Anyway, so what do we do? So at that moment, you are sensing, you are feeling that sensation, but you are not really recording anything. But what if you stand with a thermometer? It could be digital, it could be analog, and then you start noting down the temperature around you. That means you are sitting by the fire, and then you are recording the temperature that you are, being recorded on the thermometer. So at the beginning, it might be, I don't know, 40 degrees. Then it might be 35 degrees, or at the beginning, it could be 30 degrees. Then it could be 25 degrees after half an hour. Then it could be 20 degrees after even half an hour. That is 1 hour from the beginning. And after 30 hours, it could be 16 degrees. So now you are doing some analysis of that information. Let's say that, okay, so each half an hour, 5 degrees Celsius of temperature is dropping. So that means the logs or the woods that you are putting in, they are burning out, and they cannot give you any more heat, and that's why the temperature is dropping. So that means maybe you need something else to keep the fire going for longer time. Okay, so that you get temperature even, or you can keep the temperature stable more than 30 minutes. So the 5 degrees centigrade is not dropping in every half an hour. Okay, it's more stable and stable for longer time. So you can do such analysis in reality. So why can't you do it from satellites or any other devices? So remote sensing does the same thing. So what it does is it sends, and after sensing, these information, they get recorded. Okay, and what are these information? These information are the reflected or the emitted energy. So why it says two important terminologies, reflected and emitted? Because sun is the source of energy in our solar system, the primary source of energy in our solar system. Okay, so sun is emitting the energies, the light, and then these energies come into our atmosphere, enter our atmosphere, then drop or incident on the surface of Earth, and then these energies, they get reflected back to the atmosphere and to the space. Okay, so that one is the reflected energy. But sometimes we are also emitting energy. For example, you are lighting up the streets at night or the cities at night. You are driving cars, so the lights are being emitted from the headlights of your car. You lit up the streets to prevent crimes and to see where you are going at night. So these lights, they are also being emitted from the bulbs or any media that you use. So there are two sorts of energy that is going from Earth to space. So one sort of energy is the reflected energy, and the source of that energy could be sun or something else. Okay, that could be sun or that could be moon. So moon is a satellite. It's a natural satellite. Okay, so the moon in full moon, in a night of full moon, what do you see? Everything is brightened up. Why? Because the moon has reflected energy of the sun, and then from by using that energy, now the surface of Earth is visible. Okay, we're using that energy. So, and then that energy again being reflected from the surface of Earth. So my point is, it's not always it's not always that sun directly becomes the source of energy. Sometimes something else is being the source of energy, be that direct source or indirect source. For example, moon is being the indirect source of energy, not the source of energy, but it's sending us the energy, it's reflecting the energy towards us. So that way it's the source of energy, although in reality it doesn't really have any energy within, maybe or might not be. Anyway, so that is the reflected part, and the emitted part is the energy that we are producing on the surface of Earth, and then we're releasing it, and eventually it's going to the space. Okay, so we record all this reflected and emitted energy, and then we process this information. After processing, we analyze this information. So what do we mean by processing? When we collect some energy, or when you collect anything, you could have some errors. So these errors need to be omitted. Okay. So for example, when you were collecting the, when you were measuring the heat or the temperature of the fire, when you were sitting by the fire in a wintry evening or morning, there could be some errors arising from the device. For example, you did not calibrate the device beforehand, or maybe you put the device, maybe you stood between the device and the fire. So let me draw something. So for example, this is the fire. Okay, the fire is going. This is the thermometer. Okay, and here is you. Sorry, this is you. Okay, and then here is the thermometer. So in this aspect, although this one is not a very good example, but you might be blocking some of the energies, or even you might be being source of some energy to the thermometer, since you are in between the fire and the thermometer. So there could be two possibilities. Two sorts of error could be arising from this scenario. One error could be that you are blocking this energy. That means you are absorbing some of the energy from the fire. So the energy that directly should be falling onto the thermometer. Okay, so you are absorbing some of the energies, blocking some way. So the other energies, they are going around, they are still being sensed by the thermometer, but not the direct one, because you are on the way. And then you release some of the energy to the thermometer. Okay, but that energy is not as strong, might not be as strong as the fire. So now your thermometer is giving some records which are which have some bias within it, or which have some errors in it. So we need to remove that error before we make a decision based on that. So that is what comes into the processing. The part of this processing, the phase or the step of processing, is to remove the errors. So afterwards, what we do is we analyze the records or the information that we got. So after analyzing that information, finally we apply in reality. Okay, so to summarize this slide, remote sensing, it's a science, and sometimes it's art, which sense or record information without being physically in touch with the surface of Earth. And when we do that, we sense the information, or we sense the energy, we sense the reflected or emitted energy, and then we record that reflected or emitted energy. And then we take these recordings, we process them. That means we try to remove the errors from it, and then we analyze that information. And finally, the information that we receive from the analysis, we apply that information in reality. Okay, we make a decision from it. So that is the definition. That is the sense of it. So if I ask you what is remote sensing, you do not really have to write this down. If you do write this down, that is very good. But if you can't, that's fine as well. Because you can always find this definition from websites, and you can find more definitions from many other authors and books and websites. So it doesn't really matter what do you write, but as long as you write the main idea of this, that it's a science, sometimes art, and then what it does is it sends something without being physically in touch. That could be Earth's surface or anything. Okay, for example, sonar. So sonar technology is part of remote sensing. Ultrasonography is remote sensing in some ways. Okay, so yeah. And the formal definition was given by ASPRS, and it says that remote sensing is the measurement or acquisition of information of some property of an object or phenomenon by a recording device that is not in physically or intimate contact with the object or phenomenon under study. So previous examples were mostly focused on the remote sensing that we know. The traditional or the conventional remote sensing that we talk about in our study, or in the world of remote sensing. That is, in the conventional remote sensing, we always want to monitor the surface of Earth. I mean, the Earth's surface is our main concern. Okay, so that is why in this definition by Natural Resource Canada, it talks about the Earth's surface, not the other surfaces. But sometimes we also observe other surfaces. For example, Mars. We try to observe the surface of Mars. We try to observe the surface of Jupiter. We try to observe the surface of Moon. And sometimes with all the telescopes and other scientific tools, we try to monitor the surface of Sun. How is it changing? Okay, is there any anomaly going on, etc., etc. So this definition is more formal because it doesn't really limit you with within the Earth's surface. Rather, it talks you about the property, and sometimes it says it could be more than property. That means it could be a phenomenon. For example, if you talk about sun, the sun itself, it's a star, it's an object. But then when sometimes there is a fire flaring up, that one is not an object. That's a phenomenon. And then you are sitting, I don't know, in Bangladesh maybe, okay? You are in an observatory in Bangladesh, and then you are observing the sun from a very, very long distance with very sophisticated device. And then you notice that there is something going on. I mean, the fires are really flaring up in some parts of the sun and really, not flaring up, rather minimizing or mitigating in some part of the sun. So that is not an object, that is the phenomenon there that we are talking about. And then when you are observing it and you are recording that scenes or those scenes, or you are maybe taking photo or recording the video or taking video and storing them in a computer, that one is still remote sensing. Okay, but this remote sensing is not that popular. I mean, it's not very easily found. Only few observatories or few scientists, they are using that source of remote sensing. Okay, most of the remote sensing experts, they are focusing on the more conventional and traditional remote sensing, for example, observing the surface of Earth. And also, we gave an example of photogrammetry, if you can recall, that how the cars are being tested in the labs. So you put multiple dots on the cars, you set up multiple cameras, and then you speed up the car and send it to some object, and then it crashes, right? And based on that, based on how take the impact and how could it sustain, and which parts of the car cannot sustain that impact. We observe this based on the location of these multiple dots on the surface of this car. Okay, and also as well as the surface on the dummy who is supposed to be the passenger or the driver in the car. So we called it photogrammetry in our previous classes. So that one is also, you are not being in the car, you are not on the car when you are observing that impact. You are farther away, you are in a safe distance with the camera, you are recording it, and then later on you are measuring, you are processing the information, and you are trying to measure the impact, okay, how forceful it was, and you are trying to find out why did it happen, why some part of the cars are more vulnerable than others, and you try to improve the design of that car, or you try to certify the safety of that car, and so on. So that is also remote sensing. Okay, so this is more formal definition of remote sensing. So in your exam, if you write this definition, not exactly, but the idea of it, that is also fine by me. So we have seen, yes.
আমার একটা কোশ্চেন স্যার, সব স্যাটেলাইটে কি রিমোট সেন্সিং ইউজ করা হয়?
না, সব স্যাটেলাইটে রিমোট সেন্সিং ইউজ করা হয় না। যেমন বঙ্গবন্ধু স্যাটেলাইট, as we were discussing in our previous class, that Bangabandhu satellite is a communication satellite, so it doesn't really sense anything. Okay, so since it does not sense anything, it is not remote sensing satellite. It's a communication satellite. It takes some signal and then it relays that signal to other satellites or some receivers. So these receivers are, for example, we have Akash, you know the antenna Akash DTH.
Yes, sir.
Right? Yes, so Akash, I don't know whether the full name is DTH, Akash DTH, or simply Akash. So that one is getting signal from Bangabandhu satellite. Okay, it's receiving the signal.
Sir.
Yes.
Sir, তাহলে কি স্যার কমিউনিকেশন স্যাটেলাইট যেগুলো আছে সেগুলো স্যার রিমোট সেন্সিং হিসাবে মানে কাজ করে না স্যার? এটাই কি স্যার মেইনলি সামারিটা?
ইয়েস, সেটার রিমোট সেন্সিং হিসেবে কাজ করে না। বিকজ দেখো, রিমোট সেন্সিং এ কি বললাম, ইউ হ্যাভ টু সেন্স সামথিং, রাইট? আই মিন তুমি আগুনের পাশে বসে আছো, এক্সকিউজ মি, শীতের সময় তুমি আগুনের পাশে বসে আছো, তো তুমি কি ফিল করছো? গরম ফিল করছো, তাই তো? এখন আমি তোমার গ্রামের বাড়িতে গিয়েছি, আমি বললাম ভাই আমার আগুন তো ভয় লাগে, আমি একটু দূরে বসবো। তুমি যখন আগুনের পাশে বসছো, তোমার গায়ে চাদর লাগছে না, তোমার গায়ে সোয়েটার দিতে হচ্ছে না, জ্যাকেট দিতে হচ্ছে না। এখন আমি আরেকটু দূরে যখন বসলাম, আমি কিন্তু আগুনের হিটটা ফিল করছি না। তো আমাকে কি করতে হচ্ছে? একটা জ্যাকেট, একটা চাদর, শাল বা কিছু একটা আমাকে গায়ে দিতে হচ্ছে, প্রিজার্ভ মাই হিট। Why? Because I'm failing to sense that energy that is being emitted from the fire. Okay, so বঙ্গবন্ধু স্যাটেলাইট তো কোনো কিছু সে ফিল করতে পারে না। ওকে, সে কোনো কিছুই সেন্স করতে পারছে না। সে যে জিনিসটা করছে, আমি যদি তোমাকে এখন একটা ফোন কল দিই, ধরো এই যে সৈকতই মনে হয় কথা বললা, সৈকতকে আমি ফোন কল দিলাম, হ্যাঁ সৈকত তুমি বাকি ক্লাসকে এই জিনিসটা জানিয়ে দাও, এই ইনফরমেশন যে আগামীকালকে ক্লাস টেস্ট। সৈকত করলো কি, যে তখন ফেসবুকে বসলো, বসে গ্রুপে পোস্ট দিল কালকে ক্লাস টেস্ট আছে, সিলেবাস হচ্ছে এটা। সো এখানে কি কোনো কিছু সেন্স করার আছে এক্সেপ্ট হিয়ারিং?
নো স্যার।
রাইট? সো ফিজিক্যালি কিন্তু সারফেসে কিন্তু তুমি কোনো কিছুই সেন্স করছো না। সো যেহেতু সেন্স করছো না, সো দিস ইজ নট রিয়েলি রিমোট সেন্সিং। বাট এখন ধরো সৈকতের বাসা হচ্ছে, সৈকত থাকে হচ্ছে আমার নেক্সট বিল্ডিং এ, রাস্তার এপারে ওপারে। তো আমি ছাদে গেলাম, সৈকতও ছাদে গেল একই সময়ে। আমি এখন সৈকত সাইন ল্যাঙ্গুয়েজ পারি, আমিও সাইন ল্যাঙ্গুয়েজ পারি, কথার কথা। তো এখন ছাদে সৈকতকে দেখে আমি সাইন ল্যাঙ্গুয়েজে বললাম, সৈকত কেমন আছো, দেখা হয়ে ভালো লাগলো, সাইন ল্যাঙ্গুয়েজে বলছি, কিন্তু সে আমার কথা শুনছে না, তার বাসা একটু দূরে। ওকে, তারপরে বললাম কালকে কিন্তু ক্লাস টেস্ট, ক্লাসের সবাইকে জানিয়ে দাও। সো এখানে কিন্তু সৈকত আবার সে কি করছে, সে কিন্তু সেন্স করছে। কি সেন্স করছে? আমার হাতের মুভমেন্ট, আঙ্গুলের মুভমেন্ট সে দেখতে পাচ্ছে। দেখে দেখে সে সামথিং, সে একটা মেসেজ, সে একটা রেকর্ড করছে। ওকে, সো এটা কিন্তু আবার রিমোট সেন্সিং। বুঝতে পেরেছো?
ইয়েস স্যার।
অর্থাৎ সারফেসের, আমি আমার আঙ্গুল, হাত সবই তো আমার বডির সারফেস। সো আমার সারফেসে কোনো মুভমেন্ট হচ্ছে, এটা তুমি দেখতে পাচ্ছ। ওকে, বাট ওই যে তুমি ফোনে আমি কথা বললাম, শুনলা, তারপর এটাকে রিলে করে দিলাম মাল্টিপল জায়গায়, এই জায়গায় কিন্তু তুমি আসলে ওই মানে ওই আসপেক্টে, দেখার আসপেক্টে বা সেন্স করার আসপেক্টে তুমি আসলে সেন্স করছো না। সো দ্যাট ইজ নট রিমোট সেন্সিং। সো in that way, Bangabandhu satellite is not a remote sensing satellite. So all communication satellite, they play some roles in remote sensing. We will come to that. They play important role, rather important roles. However, they are not remote sensing satellite per se. Okay, so আমার মনে হয় question answer হয়েছে। Let us move on to this slide. So we have seen that GIS is a multidimensional subject, and just like GIS, remote sensing is also multidimensional field of study or branch of science. It mostly involves the technology and the idea and the techniques involved in remote sensing. And as I explained previously, that you have to have the locations or locational information embedded with the data collection in remote sensing. And by saying that, if I simply put, in our previous example, when we talked about collection of SAR data or any remotely sensed data, we say that you have to have a very good GPS built in with the machine, which one records the location of the device in a real time. Okay, so since we are talking about GPS, since we are talking about the location of data collection is crucial in remote sensing, that hence comes the geodesy and surveying. Because geodesy and surveying, what it does is it finds out the location. It talks about location. It talks about projection. It talks about coordinate systems. It talks about how can I find my location somewhere, be that the surface of Earth, be that not surface, be that in the atmosphere, okay, be that somewhere else in some planet, be that in Mars, Jupiter, or on the moon. So geodesy and surveying is that field of study to find the location. Okay, so therefore these two major fields are interconnected. And then what do? You collect your data, you know the location of your data, you fix your errors, that means you process the data, and now you have to do the analysis. So since these analyses, they involve location, therefore comes GIS. So most of the remote sensing data, they get analyzed in GIS environment. So sometimes you will see that you will be processing remote sensing data in more sophisticated or remote sensing oriented softwares. For example, ENVI or EIRDAS Imagine or something else. For example, eCognition. Okay, eCognition. So after processing the data in those software or preparing the data in the software, then you will be bringing that bringing this data, this processed or prepared data, into GIS softwares. Okay, for example, ArcGIS or QGIS or something else. And in this GIS software, you will be doing the analysis. What sorts of analysis? For example, you have collected satellite data of Dhaka from the year of 1990 and from the year of 2020. So you have collected 2 satellite scenes, okay, of Dhaka. And then you prepare the data, you create land cover map in remote sensing software of 1990 and 2020. And now what do? The easiest way is you bring these 2 land cover information or 2 land cover maps of 1990 and 2020 into GIS environment, and then do the analysis to find out the changes between 1990 and 2020, that what happened, how the urban area have evolved within this time, how are the water bodies, how are the wetlands, how are the vegetation. Okay, so that's how GIS and remote sensing and geodesy are connected. And finally, you have done your analysis. Now you have to, show me the result or present your result for the audiences, or you have to show the result to the stakeholders. And how can you do that? I mean, we have seen that picture can, speak 1,000 words, more than words or something like that. You know the idea. So picture could contain very, or I should say more information than the words in a single and limited space. So what do we do? For that reason, we create maps. For example, you have the information of, you had the information, you got the information of land cover of Dhaka of 1990 from remote sensing or in remote sensing, and 2020 both. You have the land cover map, so you get the land cover map, so LC, and then you bring them into GIS, and then you find out the changes between the land covers, how they change. So you have changes now, CNG change, and now you want to show or display these changes so that by looking into something, audiences or the target audiences or other scientists, they could understand how much change had happened, okay, without going through multiple data. That means multiple numbers and digits, which is very difficult to comprehend sometimes if there is a lot. So what do? You make another map, okay, of this change. So that's how cartography is involved with both GIS and then remote sensing. And why do I say directly remote sensing? Because you have created these land cover maps. I did not say these are images. I said these are land cover maps. So in the remote sensing, you created land cover maps by using the cartography skills and the theories. And then you took it to the GIS, you did further analysis, and then you also created another cartographic product. That means you created another maps. And while doing so, that means while collecting the data, you preserved the information of location. While analyzing the data in GIS, you preserved the locational information. While creating the map, you again preserved the locational information. So that way, geodesy, which will be your subject in 4th year, I think, the geodesy and surveying plays its role all over this tree. So that's why it's at the front. So it's playing its role on all these three. Okay. And then remote sensing is being interconnected with both cartography and GIS. So that's why it's on the 2nd layer. And GIS and cartography are interconnected always. So they are at the same layer. So that is, and okay, so with these 4 major field of studies, we apply the mathematics and logics of remote sensing and GIS. Okay. And once all these products are ready, the data are ready, the results are ready, now we can incorporate other fields of studies. For example, biological sciences, physical sciences, environmental sciences, social sciences, and so on. Okay, so now you say that, okay, so the urban area is changing. I mean, it has changed, or land cover has changed from 1990 to 2020 using this pattern. Now let's try to relate them or connect them with the socioeconomic status of the people, okay, or the policies that has been developed, implemented, modified, rectified, and so on. Okay, what happened? How these aspects of socioeconomic changes has influenced the change in land cover. That way, you see, we are connecting social sciences. Now we could say that, okay, how about the vegetation? How this vegetation has changed within these 30 years from 1990 to 2020. So vegetation is another land cover class. So it has changed, and then we are bringing in the biological sciences to observe this vegetation, or how much carbon has released because of deforestation in Dhaka area, or thinning of the vegetation in Dhaka area, how much carbon has been released, or how much carbon stock has reduced over these last 30 years. We talk about all these things. We also talk about how the landforms have changed, why there are more frequent waterlogging in recent times than the past, and why there are less flood in the Dhaka city area than the past. However, there are more frequent floods outside of Dhaka city in Dhaka, okay, not in the city area, but outside of the city area. So these are the things that physical sciences, they are coming in. And then you are talking about, okay, so how the changes in land cover is influencing the environment, then you are bringing in the environmental science. Okay, so environmental sciences is in many ways, it's part of biological sciences as well, but it's also one of the major field of study where the GIS and remote sensing is highly used. Then you also bring in agriculture, another important aspect. Okay, and you observe how that these land cover changes or other variables, they're influencing the production of different agricultural crops. Okay, so and so on. So if we summarize this, we can say that geodesy and surveying, that is, location is very important. So since the beginning of this course and GIS, I've been saying it repeatedly, that location is very important. To know your locations, to know your location and the location of other entities around you is very important. So that's why GIS and surveying is at the top level, and it's having influence or having interconnectivity with all these three other major field of sciences. And the remote sensing, it's connected with geodesy and surveying. Then it's also having connected with cartography and then GIS, because to make the products, it's taking the help of cartography. Also to process the data, it's taking help of cartography. And then it's sending this data, it's sending the result to GIS for further analysis. And GIS is again using cartography to present the result. And finally, we are bringing in other subjects, for example, mathematics and logics to do the analysis, and then applying the finding result by incorporating or applying the finding results into other field of studies. For example, social sciences, by incorporating its variables or its factors. For example, the income of people, and then the policies regarding the development. Okay, that means housing development and so on. So I have already discussed. Yes.
স্যার, আমরা যখন মানে একটা রিমোট সেন্সিং থেকে ইনফরমেশন কালেক্ট করে এটা ম্যাপে শো করি, তাহলে ওইটাই কি কার্টোগ্রাফি হয়ে যাচ্ছে আমাদের? মানে ম্যাপে
So-
শো করাটাই কার্টোগ্রাফি, কারণ কার্টোগ্রাফি তো ম্যাপ রিলেটেড ডিল করে।
Right. So anything that you anything that is mapping involved, that is cartography. So তুমি যদি একটা সিম্পল একটা ম্যাপ বানাও, তুমি যদি হাতেও এঁকে যদি ম্যাপ করো তাহলে সেটা কার্টোগ্রাফি। সো ওই সেন্সে হচ্ছে রিমোট সেন্সিং এর যে প্রোডাক্ট গুলো হচ্ছে সেগুলো আবার মানে কার্টোগ্রাফিক ইয়াটাকে বজায় রাখে আর কি, কি বলে থিওরিকে বা সায়েন্সকে ইউজ করে। ফর এক্সাম্পল তুমি যখন রিমোট সেন্সিং এর ডেটা বানালা, সো রিমোট সেন্সিং এর ডেটার ওখানে তো যখন রিভার বডি ক্লাসটা তুমি তৈরি করছো, ওই যে আমি ল্যান্ড কাভারের কথা বললাম না, সো ল্যান্ড কাভারের সময় তুমি যখন ওয়াটার বডি তুমি যখন আইডেন্টিফাই করছো, ইউ আর অলওয়েজ মেকিং ইট ব্লু, giving the blue color. Why? Because cartography says that water should always be blue. তুমি যখন কোনো ভেজিটেশনকে আইডেন্টিফাই করো, তুমি সবসময় এটাকে সবুজ রাখো বা ইয়েলো রাখতে পারো, ওকে, বাট মোস্টলি সবুজ রাখে, এনি শেডের সবুজ। কেন? বিকজ কার্টোগ্রাফি অর্থাৎ as a theory or as a science, cartography says that vegetation should be green or should be represented by the green color. আবার তুমি যখন কথার কথা তুমি যখন আরবান এরিয়াকে রিপ্রেজেন্ট করছো বা বেয়ার সয়েলকে রিপ্রেজেন্ট করছো, তো বেয়ার সয়েল নরমালি তোমার ইয়েলো অথবা তোমার ব্রাউন কালার দিয়ে রিপ্রেজেন্ট করা হয়। ওকে, সো তোমরা কাজ করতে করতে ইন ফিউচারে কাজ করতে করতে এই সেন্স গুলো তোমাদের ভিতরে অটোমেটিক চলে আসবে, এবং কে এই সেন্স গুলোকে তৈরি করে দিবে? ইটস কার্টোগ্রাফি। তো আমার মনে হয় কোশ্চেনের অ্যান্সার হয়েছে। কোনো ফার্দার কোশ্চেন কি আছে?
না স্যার।
Okay. So I think I have already discussed some of these, that what is it for. So there are 9 things are listed, or 9 fields are listed here. The first one is agriculture, followed by forest, soil, water resource, and finally disaster warning and management. However, this is not exhaustive. There are many more fields where you can apply remote sensing. So the first one, we may talk about agriculture, because it's one of the field that is highly and very highly used in remote sensing, or this field uses remote sensing technology. For example, in Western world, precision farming is very popular. So what is a precision farming? I think I have already discussed precision farming in our previous classes. One of the explanation was such that in precision farming, you know exactly where the things are. So you are cultivating acres and acres of land, maybe 100 acres of land. So for cultivating such big area, you have to have, I mean, a lot of manpower, a lot of expenses involved if you do it in a country like us. Okay. So in Western world, or in developed world or countries, what they do is they use remote sensing technology to monitor everything. Instead of having a lot of manpower, they have satellites and they have drones. Okay, so these satellites and drones, they fly on the field and they collect data. Okay, and what do? You capture this data, you bring this data, and sometimes there are field technicians. What do? They go to the field and verify. They collect random data. For example, these satellites have collected data on this field, and these field technicians, they go and they collected information on the health of this vegetation from point here and this point. Okay, and maybe this point, in these 3 points. So satellite has collected the information of vegetation health throughout this field, for this entire field. So you bring in the information that was derived from the satellite, and also you bring in the field data. So you have, for example, you see there are pixels, block cells. So you have these cells, and then what do you do is that, okay, so your satellite gives that the health of vegetation is 1 at this location, that is this block, for example, this block, okay, the value is 1 in a scale of 1 to 5. That means the vegetation is dying out or on or highly stressed at this location. So that location is, for example, this one. Okay, so your field data, so I'm going to write it outside. So your field data says that the stress level or the health of vegetation is 1.1 here at this location. And then your satellite have collected at this location, the health of vegetation is 2 on a scale of 5. So the vegetation is improving, obviously, the health of the vegetation. And your field data said that this location, at this location, your vegetation has 1.9 at 1.9 scale. Similarly, at this point, so this is 0.2 and this is 3, okay, third location. At this point, your satellite says this is 5, so it's very healthy, okay? And your machine, that is the field data, says that it's 4.8. So how do you, what do you do now? What do they mean, these satellite data and field data? Because satellite data could sometimes be not right, could be wrong. So that's why we need to do accuracy assessment on satellite information, okay, or the information that was retrieved by the satellite, that was recorded by the satellite or other devices. So we have collected the results from the satellite data, and that's why we go to random points on the field and collect the actual data, because you cannot go to every point in this 100 acres of land and collect the data. That would be in that way, we will be needing maybe hundreds of field technicians. Instead, you appoint these 2 guys, and then you tell them that, okay, go to these points, go to multiple points, and then collect the actual data of plants' health. So they collected these 3 points, and these are the actual information of the plant vegetation's health. And then you found out that, okay, the result that I'm getting from satellites, they are actually very close to the actual data. That means I can really use this information, because these information have very, very minimum error, okay? Is very marginal error. So this error can be overlooked or omitted. That means tumi error ke ki korte paro, ignore korte paro. So now what do? You have hundreds acres of land, so you map out the vegetation health in it, and you find out that, okay, so at this location the vegetation is worse, and eventually the health of vegetation has increased. And why is that? You looked in, then you found out that the irrigation line went through this way. So these vegetations are actually getting irrigated very regularly, whereas these vegetations, they are not irrigated regularly, or the pesticides were not applied in this location. So what do? You turn on a switch from here, and the irrigation, the sprinklers, they come up in these locations, and then they started irrigating this area of the field. As a result, in next few weeks or months, the health of the vegetation improves in all over the field, and at the end of the season, you have very high yield from this field, and you make profits. So that's how precision farming works. Precision farming, by using remote sensing technology, it precisely finds out the location of the problem and precisely finds out the problem. Okay, it precisely finds out where is the problem, what is the problem, okay, and how to solve it. So by where is the problem, it finds out the location of the problem. That means where the vegetation is having some disease or having less water. Then it finds out what the problem that is, the problem that the disease or the lack of water irrigation. Then how to solve it is now okay. So you just turn it on the switch for a specific sprinkler, or you send an UV or some people to spread the or put the pesticide in some specific region of your cultivated field or agricultural field. So that way you can manage hundreds and hundreds of acres. So there is just one very, very small example of how remote sensing is being used, and other being used in agriculture, and other applications are, for example, making inventory of the agricultural fields or having statistics of their yields throughout the multiple years, that is the time series analysis, and also the damage reports, yield estimates, and so on. Okay, so if you go to in India or Nepal or even Pakistan or even other developed nations, you will find that the multiple researches are going on in agricultural field which are based on GIS and remote sensing. For example, I think you have heard of Sohanur Rahman. He did his PhD in agriculture. So he did his PhD in GIS and remote sensing, but the field that he applied that GIS and remote sensing is agriculture. He was dealing with the health of crops, so crop health. Okay, he was trying to find out the crop health and so on. He was trying to develop something. So you see, so that means when you were studying disaster management, not necessarily you have to be confine yourself within only disaster management. And by the way, Dr. Sohanur Rahman is an assistant professor in JITPAS. So you see, JITPAS directly works with disaster management, very connected to disaster management. So, for example, if you are working in, or if you are with a disaster management field, and you have to really talk about or deal with food insecurity. So when you are talking about food security or food insecurity, then we are dealing with agriculture. So agriculture comes in, GIS comes in, remote sensing comes in, and you can go and study there, and you can get your degree in, I don't know, still being disaster management, but get the degree in GIS and remote sensing by applying the techniques in agriculture. And thus, you are again coming back to disaster management because you are working with food security. Okay, so that way everything's are connected, and I think that way we can focus, we can connect our professions and applications of these tools and techniques. So another example of agriculture is such. Can you tell me what are these?
Sir, these are farms, actually irrigation based farm projects, underground water based actually. These are seen mainly in desert areas or like the areas which has less waters.
Mm-hmm. Right, exactly. And why are they round?
Because
I mean, why are they circular shape?
Because sir, in the center, the pump is actually in the center, and there is a huge pipe or what we can just call the sprinkler, and the sprinkler rotates by circling the pump. So as it circles, it creates a circular shape.
Exactly. So বাকিরা সবাই বুঝতে পেরেছো সাদমান কি বলেছে? So these are, you see,
yes,
from here we can see it's Landsat 7. The data were collected by Landsat 7. So this involves Egypt, Israel, Jordan in January 2000, and we can see the vegetation. Excuse me. It's a desert area, and then vegetation are in this location. This red color means the vegetation is 453. So maybe on stress. Okay. Anyway, so this is a combination. We will talk about these combinations. So you have multiple channels of wavelengths, and you combine them to find out some initial information from them. So in desert area, the water is very scarce. So what they do is they dig up holes or dig up wells, and they find that they set up one sprinkler, and then since if you have one source and if you make it circular, that means you have equal distance in all directions. So that's why they have these shapes for their farms or the agriculture. So this practice is not only in Middle East or in Northern Africa, this is also being practiced in some other parts, for example, in USA. Okay, so in USA, you see how they look like. So this is one of the initial pictures, or it's at the initial stage. We do not have any cartographic information. We did not create any map in this photo. We have our satellite image, and all it did was we made some, combination of the bands or all the channels that we have. We put 3 channels together and then one more channel, and we try to find out by just looking into it. We try to do some visual observation. We did not really find any actual information or anything. In the second image, however, we created one map, you see. So that's why in previous example, there is no north arrow or anything, no classification, okay? Because this is just an image, it's a scene, a satellite image, that's all, nothing else. In the second image, however, this illustration, this one is a map, which was derived from one of the satellite image or multiple images. So in this map, you see we have a north arrow. So this side is the north, okay? And the scale, so this is 1 kilometer. This one is being represented 1 kilometer. So there is, if we go till this, 2 kilometers, 3 kilometers, and so on. And then we have also our legend bar, and it says that red color represents stressed vegetation. That means this vegetation is stressed. These vegetations are in stress, as well as these vegetations. So that means the irrigation process is going through or being used in this area. Maybe the irrigation has stopped in this area, or the well that we have has dried out. So we are failing to irrigate in this region. And then these fields and therefore these fields might be already abandoned by the farmers, okay, as well as these fields. However, these fields are dry and bare ground, so we are not really using anything in this region. On the other hand, so these are also abundant. So another explanation could be these fields are abundant, that's why they are dry, okay, dry vegetation or bare ground. This is still being cultivated, but having less water, thus this is stressed vegetation. And these are the regions where we have green vegetations. That means we are still cultivating and we have ample of water to irrigate in this region. Okay. So one more quick example, okay, you see. So this is the agricultural field, or we have multiple fields, and in these fields, these are the lines of the sprinklers. Okay, these are the lines of sprinklers. So they have this line visible very clearly. And the red are the stressed vegetation, and the greens are the vegetation without any stress. So for some specific reason, maybe the vegetation at the center are more stressed than the periphery in this field, but in this field they are less stress, and same is in this field. So in this scene, multiple images have been overlapped. So these are the satellite images, you see the trees are not considered or are not mapped out as vegetation, and then these specific vegetation fields were overlaid on the background of these actual fields. So আমি যে কথাটা বলছি বাংলা একটু করে রিক্যাপ করি, সেটা হচ্ছে এই জিনিসগুলোকে ম্যাপ করা হয়েছে, এই ফিল্ডগুলোকে স্যাটেলাইট ইমেজ দিয়ে ম্যাপ করা হয়েছে। দেখো এরকম স্পেসিফিক বাউন্ডারি তারা ক্যারি করছে। ম্যাপ করার পরে তারপরে এগুলোকে কি করা হয়েছে, আমাদের যে স্যাটেলাইট ইমেজের যে একটা ব্যাকগ্রাউন্ড আছে সেই ব্যাকগ্রাউন্ডের উপরে এই ইমেজটাকে বসিয়ে দেওয়া হয়েছে। সো আমাদের এখানে অ্যাকচুয়ালি দুটো ইমেজ আছে, একটা হচ্ছে ব্যাকগ্রাউন্ডের যেটা হচ্ছে পিওর স্যাটেলাইট ইমেজ, ইটস নট প্রসেসড, ওকে মেবি ইটস প্রসেসড বাট স্টিল ইটস নট ম্যাপড আউট, এখানে কোনো ম্যাপ করা হয়নি, কিন্তু এগুলোতে আবার ম্যাপ করে ফেলা হয়েছে, অর্থাৎ কতটুকু স্ট্রেসে আছে, কতটুকু ওয়াটার কন্টেন্ট অ্যাভেলেবল আছে সেগুলো এখানে ম্যাপ করা হয়েছে, ম্যাপ করে একটার উপরে আরেকটা বসিয়ে দেওয়া হয়েছে। Okay, so I think we are at the end of the class for today. We will be continuing this lecture in our coming lecture, and then we will complete it and move on to the next lecture by this week, I think. Some text. Okay. কারো কোনো প্রশ্ন আছে? মাঝখানে কি মিটিং অফ হয়ে গিয়েছিল? হ্যালো,
নো স্যার।
হয়নি না? তাহলে এই 25 মিনিট যেটা, এটা মনে হয় আগের ভিডিও। ওকে, কারো কোনো প্রশ্ন আছে? Anyone have any question?
No, sir.
All
স্যার
right.
একটা বিষয় স্যার,
হ্যাঁ বলো।
স্যার
এটা কি
সেটা হচ্ছে
প্রশ্ন
যে
নাকি ক্লাসের বাইরের বিষয়?
না স্যার ক্লাসের ভেতরের বিষয় স্যার, মানে সেটা হচ্ছে স্যার মানে আমাদের অনলাইনে ক্লাস করতে গেলে স্যার দেখা যায় যে একটা না মনোযোগ স্যার অনেকক্ষণ থাকে না, মানে স্যার অনলাইনে ক্লাস করতে গেলে যেমন ক্লাসের ভিতরে যেরকম একটা পরিবেশ থাকে।
Okay, so that one is not relevant to the subject. We will discuss it later. মাহফুজ হ্যান্ড রেজ করেছে, কোনো প্রশ্ন মাহফুজ সাবজেক্ট রিলেটেড?
জি স্যার। স্যার
হ্যাঁ।
এমন কোন মেটাল অর সামথিং কি আছে যেটা মানে জিআইএস সেন্স করতে পারে না বা স্যাটেলাইটে সেন্স করা পসিবল না?
মেটাল
বা এনি এলিমেন্ট বা সামথিং।
মেটাল অর মিনারেল, রাইট? তাই তো?
ইয়েস স্যার।
এটা তো আসলে ডেফিনিট কোনো অ্যান্সার নেই, বিকজ you can sense many things at this point of time. I mean, the technology has really advanced. কয়েকদিন আগে আমি প্ল্যানেটের একটা ইমেল পেয়েছি। সো প্ল্যানেট হচ্ছে একটা কোম্পানি। সো তারা এখন বলছে যে তারা few সেন্টিমিটার অর ইভেন মিলিমিটার রেজুলেশনে তারা ইমেজ ক্যাপচার করতে পারছে। তার মানে ওই যে আমরা দেখি না অনেক সময় আমেরিকান মানে মুভিতে যে সিআইএ অনেক জুম টুম করে তারপরে পুরো লোকজনকে দেখে ফেলছে, they can actually do that now. মানে কমার্শিয়াল স্যাটেলাইট, প্ল্যানেটের যে স্যাটেলাইটটা সেটা কমার্শিয়াল, এবং তুমি টাকা দিয়ে তুমি এই ডেটা কিনতে পারবে। বাট নাও ইউ ক্যান ডু দ্যাট, এন্ড ওয়েন ইউ ক্যান ডু দ্যাট ইউ ক্যান অ্যাকচুয়ালি ডিটেক্ট ইফ ইউ হ্যাভ দ্য সিগন্যালস অ্যাভেলেবল। সো কি সিগন্যাল অ্যাভেলেবল বলতে কি জিনিস, সেটা আমরা পরবর্তী ক্লাসগুলোতে দেখবো, যে স্পেসিফিক ওয়েভলেংথে স্পেসিফিক অবজেক্ট এক একভাবে বিহেভ করে। ওকে, সো মিনারেল, তুমি ধরো কথা তুমি ধাতুর ভিতরে অ্যালুমিনিয়ামের কথা বলছো, সো তোমার একটা অ্যালুমিনিয়াম কোনো একটা জায়গায় রেখেছো, বি দ্যাট লেটস সে তোমার অ্যালুমিনিয়াম একটা পট রেখেছো একটা জায়গায়, সো এটা তুমি ডিটেক্ট করতে পারবে কিনা। ওই অ্যালুমিনিয়াম ধরো স্পেসিফিক ওয়েভলেংথে যেভাবে বিহেভ করে, ওই ওয়েভলেংথে তোমার স্যাটেলাইট যদি ডেটা কালেক্ট করে থাকে, ইউ ক্যান অলওয়েজ ডিটেক্ট অ্যালুমিনিয়াম। ওকে, so now how about, let's say for example, something that is underground, অর্থাৎ মাটির নিচেই তো খনি থাকে, তাই না? ধরো তুমি গোল্ডের, সোনার খনি তুমি খুঁজে বের করতে চাচ্ছ, or you want to find out something else. So how to find out the location of these? So এই ক্ষেত্রে হচ্ছে তখন আবার জিওলজি হচ্ছে কোয়াইট হ্যান্ডি হয়। সো জিওলজিস্টরা এই কাজে এটাকে ব্যবহার করে। তারা করে কি, তারা ওই মাটির প্রপার্টিজ তারা দেখে। সো মাটিতে যখন স্পেসিফিক কোন একটা সাবস্টেন্স তারা খুঁজে পায় বেসড অন রিমোট সেন্সিং, সো দে ক্যান নাও ন্যারো ডাউন দেয়ার এরিয়া অফ ইন্টারেস্ট এন্ড বলতে পারে যে ওকে দিস আর দ্য এরিয়াস ওয়্যার we might find some gold or you might find some gold. So geologists and then miners, they are using such technology. And same is for archaeology. So archaeology করে কি তারা হচ্ছে এরকম এইভাবে মাল্টিপল সিগন্যাল ডিটেক্ট করে স্পেসিফিক সিগন্যালের ডেটা কালেক্ট করে তারা হচ্ছে তখন বলে যে ঠিক আছে এই জায়গায় হয়তো ফার্স্ট একটা সিভিলাইজেশন ছিল, কারণ এখানে এই সয়েলটা দেখা যাচ্ছে, এই সয়েলটা দেখে মনে হচ্ছে এখানে একসময় এগ্রিকালচার হতো, বা এই সয়েলের প্রপার্টিজ দেখে মনে হচ্ছে দিস ইজ নট ন্যাচারাল। And by mean not natural, what I mean is অর্থাৎ পোড়ামাটি দিয়ে তুমি কিছু একটা করেছো, so there might be some clay pots. So when you have clay pots, the structure of the soil has changed, and since the structure of the soil has changed, the reflectance of it has changed. Okay, so তুমি যদি একটা মাটি পাও যে জায়গায় তুমি পোড়ামাটির বিভিন্ন পাত্রকে ভেঙে চুরে গুঁড়ো করে তারপরে মাটিটাকে ছড়িয়ে দিয়েছো, দেখবা ওইটা তোমাকে ডিফারেন্ট একটা রিফ্লেক্টেন্স দিচ্ছে দেন ইউজুয়াল সয়েল। ওকে, সো এইভাবেই হচ্ছে তারা তখন এগুলোকে ডিটেক্ট করে। সো তোমার কোশ্চেনের আসলে একদম ইয়েস নো টাইপের কোনো মানে অ্যানসার নাই। ওকে, ইটস আ লিটল বিট মানে ব্রড এন্ড ভেগ। ওকে, সাবজেক্ট রিলেটেড আর কোনো প্রশ্ন? প্রশ্ন নেই, so I'm going to stop the sharing as well as stop the recording. Thank you for being here today.
Thank you, sir.